Hello everybody, I will start my today another live coding session. So in my today's video, I will solve this question. Container with most water. So in this question, I'm giving an integer array height of length n. There are n vertical lines drawn such that the two endpoints of the ith line are I0 and a height I. Okay, so lowest coordinate is 0, I0, like this, and in one bar, for each bar, the highest endpoint, or as the highest edge is I, height I. Okay. And yeah, obviously the height is exactly height I. Okay. Find two lines that gather with the x-axis from the container, such as the container contains the most water. Find two lines that gather with the x-axis from a container, such that the container contains the most water. Okay. Return the maximum amount of water a container can store. I return the maximum amount of water, which is an integer. Maybe not integer, number. Yeah. Notice that you may not run the container. Okay, so I will be given the list of the height list, which is the input. And the output should be the number, which represents the maximum amount of water, which can be contained or stored. Okay. And I can say there are at least two bars. Good. So, and height, it can be 0 to some larger number. I mean, positive number. So, the edge case I will take care is like 0, 0. In this case, the water amount should be 0. Or maybe I can say if there is height 0 and 4, I should return 0, 2. But otherwise, for example, yeah, like say I have 0, 1, 2. In this case, between 1 and 2, I can store the maximum amount of water, which is mini of 1, 2 times 2 minus 1, which is amount 1. Yeah. And obviously for here and here, amount which is stored is 0. So in the end, I will return 1. Okay. Good. So obviously, the brute force approach I can take is choose the combination of every two bars and calculate the amount of water which can be stored within two bars. In those two bars, then I will return the maximum of them. As I've written in line 10, the number of water which can be stored with specific two bars is formulated like this. So the time complexity of this approach should be n squared, assuming that there are n bars given, because the number of combinations for two bars is n squared order. So the time complexity in total should be over n squared, because once I choose two bars, the amount of water can be calculated in the constant time. Yeah, so that's a brute force approach. But probably I can speed up, optimize. So when I take a look at this formula again, let me write it here. I think I can say something. So, mm, I would think with maybe a better example, but let me use this one. So in x2 minus x1 perspective, this is the largest. And mini high one h1, h2, in that perspective, I should choose here to here, 8 to 8. Yeah. Mhm. Okay. So, okay, so one thing I can say is, I will use the 2 pointers. So this should be left, and this should be right. And in this range, I can say the maximum amount of water which can be stored is, sorry, index should be 0, 1, 2, 3, 4, 5, 6, 7, and 8. Yeah. The amount of water it can be stored here, left to right, should be mean of 1 and 7 times 8 minus 0, which should be 8. And when I think of other, 2 bars pair, the distance between 2 bars is always smaller than this. But if I move the, say, left pointer, what happens is that the height becomes higher. Yeah. So the second, mini of 87 times 8 minus 1. So this should be 49. So even though x2 minus x1 decreased, the mini h1, h2 increased. So in total, the amount increased. So yes. And what I can say is, if I move the right pointer or left pointer, the same thing can happen. So maybe I can increase the amount of water stored. So that being said, if I do try to check every combination, it's still n squared time complexity, just like the brute force. Everything was a smarter way. So when I move the left pointer, the right pointer, okay, I will think of it in this way. So in this way, 0 to index 0 and 8, the bottleneck for the height is this one. So in this, wherever the right pointer is moved, like this or this or this or this, the amount of water doesn't increase because mini of high 1, high 2 is always 1, or maybe it can be smaller by moving this. Sorry, yeah. Yeah. So if I move this 7 to say 8, still the meaning of h1, h2 is 1. And if I move this 7 to 0, where actually it doesn't exist, but let's think it. The meaning of one's two heights should be 0. So I cannot increase this mean h1, h2. But for x2 minus x1, this decreases. So from this left and right pointers, it doesn't work moving the right pointer. It doesn't increase the amount of water. So for this left, right position should be this last index, which could be the maximum for this left. So what I can do is, the only way I can do is to move the left pointer and calculate the amount as 49. And from here, I will think how I can increase the amount of water by moving left pointer, right pointer. I don't move the left pointer back because it already checked. Yeah. So from here, what I can do to find the more water, to find the pair which stores more water is, I will think of it in this way, the same way. So if I move the left pointer, no matter how much I move to the right, meaning h1, h2 doesn't increase. Or maybe it can be equal or decrease. And x2 minus x1, this definitely decreases because the distance between them is shortened. So the only way I can do is to move the right pointer. Then I calculate it, okay? But actually, this decrease the amount. Yeah. Wait, so I wonder if I can move the left pointer instead. Because it actually increases the amount, mini h1, h2. Yeah. So maybe it was moving this because in that way, mini is also increased. No, decreased. This is decreased. So this way I get 7. Am I correct? 6, 7, yes. No, this should be 42. Actually, this 6, 7 would store more water. 6, 3. No, 6, 7. No, right pointer is now moving right. No, it's okay. Yeah. So in this case, from here, I should have moved the left pointer. Because if I move the right pointer, this decreases the mean. Yeah. answer this. Bin 7 minus 1. I don't do this. I shouldn't do this. Yeah. So maybe another approach I can think is I decide the width of the, distance between two bars. Then I slide first with this and then this and this. And maybe if the distance is 2, I start with 1, 6 and then move it to 8, 2, 6, 5 or something like that. But still, I think this takes a square time. So I will compare this and this. Still, for this one, the bottleneck is 3, but this one bottleneck is now 6. Originally, this was like this, 8 and 7. And if I move left and right in this way, bottleneck becomes 3. And if I move this way, bottleneck now becomes 6. But this is so fortunate that I could find 6 here. If this is 1, it should be 1, 7. So it seems like I always have to move to the higher bar when I go to the center. Otherwise, the amount of water stored doesn't increase. Yeah. So wait. When I completely ignore all the bars which are not increasing into the center, it looks like a mountain. And I start from here, and I will try to see how I can increase the amount of water by moving the left pointer or right pointer to the center. And firstly, this begins from here, and then it moves to the higher bar. Yes. And I can say, if this one, 2, is higher than the bar 1, whose height is 1, this increases the amount of water stored. Let me change it a little bit. Yeah. In this case, as I said, the bottleneck is this one. So if I move this to this, the bottleneck is, fixed. But if I move this to this, the bottleneck isn't fixed. So let me think of it in this way. So when I have the right pointer at this position, the best right position should be this or this or this or this. Every possible position because it can be 100 here. In that case, I should keep moving the right pointer to this 100. No, it doesn't. Wait, so if I fix the left pointer, and if this is much smaller than this, like this, okay, I should move this. But until which place I have to move the pointer? Once this exceeds 64, it doesn't worth trying anymore. Yeah. Okay. This is where I should try until. And when I start from here, I should start from this. And I will think how much I should shrink. Because this is higher than this 59 is higher than 50. It worth moving the right pointer until this 64, which is larger than 59. After that, I don't have to move the right pointer anymore because it just decreases the amount of word. Good. So what I can say is maybe I'm doing the redundant shrinking process here and here. Once I calculate this, the amount of water which can be stored here, at least for this one, I can't compare which stores more water. Yeah. Yeah, at least they're smaller. Maybe this can store more water with this bottleneck because it's wider. And when I start from here, I start from this, and because this is decreasing, it was trying under this one. Yes. So this tail n squared time complexity. So when I move the left pointer and right pointer is here, do I have to start right pointer from here? I'm thinking, so if right pointer is here and right pointer is here, okay, at least I can say these numbers are less than 50 or equal to less than 50. So I can say this is smaller than 59, which means that this becomes the bottleneck. Yeah. Just like the case in 50. So in this range, maybe I can say until this one. For x, you know, the amount of water is 50 and something times H2 minus H1. And I can say this should be always smaller than 50. So it should be H2 times H2 minus H1. So yeah, I will check them. And for here, until I start from 59 and until the number is smaller than 59, for here, meaning of 59 and y, this. And now y is, sorry, height 2 is definitely smaller than 59, as I said here. So this should be, yep, this. And what I can say is, when I take a look at the same H2, H1 was originally index 0, but now index 1. So I can say this is smaller than L39 amount. The amount calculated in L39. So I don't have to move back the right pointer. I can start from, say, this 64, which exceeds 50. So what I can say is, for every x, move x2 to center until h2 becomes higher, and obviously in this process I have to update global, returned variable, which is amount of water. Then once this is done, then move x1 plus equal 1. Yep. And probably I will do this until x1 is smaller than x2. Okay, so this is basically what I can do. And one more thing I have to take care is the case when x1 is equal to, height 1 is equal to height 2. I have to handle that edge case. So for example, this, I start from this range, and because now 1 is larger than 1, it doesn't work moving this. So I move the left pointer by 1. Then I start from here and I shrink this. And once this is equal, I don't have to move this right pointer to 5 because it doesn't increase the amount. So I finish the, line 49, move x to center operation here, and I do x1 plus 1, so I start with 5. And here, I start from 3, I calculate the amount, and I try to shrink, and when this is equal, I don't have to shrink anymore. Yep. So this is what I can do. Oh, sorry, and this should be this. Okay, so I move the x2 while this is height 2 is shorter than h1. But if they are equal, I don't have to shrink anymore. Yeah. So I move the x1. Yeah. Okay, so this is basically what I can do. So let me implement the code. Oh, by the way, the time compression should be now O of n, because I move x1 and x2 until they meet together in line 48. Yeah, so I don't have to check every combination of x1 and x2. This takes time complexity over n. And for space complexity, it should be the constant because I don't use any non-constant data structure in my solution. Okay, so let me get started with implementation. Let me rename that right. Oh, and the return max area is not with 0. Oh, I forgot one thing I have to take care. I just extracted that, like the, I just showed the example of mountain array. I mean, the number height increases until some point, which is the top, then it decreases. But what if I have some number which is written like this? So for example, like this. In this case, again I start from this and I shrink. Yep, and I start from this and I shrink until it exceeds, yes. And I start from this and try to shrink until this 8 sees left 8, and I keep doing. Wait. And what happens is that now this 5 is smaller, so this already meets the first one, 8. I mean, the right number 8 is already larger than 5. So in that case, I can just, the right point doesn't move, but I just move the left pointer. And for this one, I can say there is no benefit to choose 5 as the left pointer over 8, because definitely 8 should be more powerful as a left pointer, because the width would be longer compared with 5, and also height is higher. So it doesn't matter. how this 5 is treated. So I can include that in my logic. Yep. But nothing happens for this 5. I calculate the amount, but it doesn't, update the global max. And also this right pointer isn't moved. So it's totally fine. Okay. Then I move the left pointer and it starts from here. And now it exists 7, so I just keep this. Good. Okay. While height left is this is the area, so I update the max area. Okay. Then I move the right pointer. Then I have to calculate the area. No. Wait. So. No. This should be this. And while this is met, I don't have to update this max area because as I said, as long as this is more than, left height, right height is less than left height, it doesn't update the max area because the distance becomes shorter, but the shorter bar is always shorter than this one until, yeah. No, wait. Okay, let me think of that later. Let me just update it here. But I will think if I need this or not. Okay, then once this is met, right height is equal or higher than left height. Then I increment the left pointer and calculate the area. But calculating the area would be done in line 73 in the next iteration, so I don't have to do it. And now I return the max area. Okay. Let me think if I need line 77 and 78 while doing the dry run. I will think of this example. And the maximum amount should be this. So it should be amount 8. Yeah. Okay, so I start with left 0 and right here. And max area is not 0. Okay. And in line 80, yes, right is larger than left, so I calculate the area. So it should be mean of 1 and 1, which is 1. And height, distance should be 4 minus 4, so this should be 4. So max area is now 4. Then what happens is that let me change a little bit. I start from this. And now, sorry, so what I wanted to check is if right is shorter than left, what happens? So let me start this. Let's start this. Here, this should be one times 5 is. The next, I would think which should be moved because right bar is shorter. I move this. And now I will calculate. So now this should be 2 times 4 is 8. Oh, so the thing is, when I'm doing the iteration, inner iteration, this can update the maximum area. So I need these two lines. Okay. Good. Let me move it to the sub method. Like this. Okay. Good. So in this way, I can calculate 8. Yes. Then, because still right pointer is smaller, in line 85, I continue the iteration. Now right pointer is moved by 1. Yes. And now max area, this area is now 3 times 3 is 9. So max area is updated to 9. Yes. Now this right pointer is larger than the left pointer. So I move the left pointer by 1. And I calculate the area. So it should be now 4 times 2 is 8. So max area is not updated in line 88. Then I go back. Sorry. So max area is not updated in line 85, and in line 86, I will check left and right. And right is larger than left, so I move the left pointer because I go out of while loop of line 87 and go to line 90. And left is now here and right is here. So now this should be 2 times 1 is 1. 2. So it doesn't update the max area. And I go back to line 85. Still left is larger than right. No, sorry. From here, I move left pointer here and the right pointer here. So there's the same, so I go to the while loop and return max area, which is now 9. Okay, so probably this is correct. Yep. And now I'm pretty sure this my logic is fine. So let me execute my code. Should be area. Good, I submit my code. Okay. One thing I have to take care is I have to finish the iteration when I move this right pointer. So I have to make sure this. Otherwise, no, wait a minute. right minus 1 is larger than left. Yep. If this is not true, left is equal to right, so or right is smaller than left, so I can't calculate the rectangle. Good, accepted. Okay, so I will quickly wrap up my today's coding practice. So today I solved the question container with most water. So I was given the list of the heights, and my task is to find find a pair of two bars which can store the maximum amount of water and then return that maximum amount of water. The brute force approach I came up with, obviously, choosing every possible pair of two bars and calculate the amount of water, then for each, and then I return the maximum one, which this takes n squared time complexity. And I optimize my solution. I find that I can use the 2 pointers, and for every left pointer, I can move the right pointer. Yeah, without moving right pointer back. So basically, the distance between left and right should be shrinked until they meet. So yeah, in that way, I can solve this question in over n time complexity. Let me quickly update my code with for loop. Maybe it can be more simple. For each left pointer, I do this, but I move right pointer only once. So yes. So in this way, for every left pointer, wait, I copied it twice. I don't know. For every left pointer, I calculate, and then left is higher than right. I move the right pointer and update the max area. And then what happens is that the left pointer is moved. That's not what I'd like to do. Maybe I still need the while loop here. But at least I don't have to iterate left pointer every time. And also, I think what I can do is, after calculating this max area, sorry, so what I mean to say is, if left is equal to right, I have to finish the iteration. Yeah, so maybe I still need this one. But yeah, I think it's a bit more easy to understand. No, I don't think this is easy to understand. Sorry, I just brought it back. Yep, I think this is good. Okay, I finished my today's coding session with this. Thank you so much. Bye.